registered for the Farm School for Women class. I know we have quite a few folks that are new this year, and we're happy to have you all on. We also have some returning folks that follow us each year with the Farm School for Women program. So we're excited to have you guys back on as well, or you ladies, I should say. So as we go through the next 3 weeks tonight and the next 2 weeks after tonight, if you all have got questions at all, there is a chat box. So we kind of leave everybody on mute during the program just to kind of cut back. I know you all probably attended Zooms and you know it gets a little cluttered of listening to background noise and that kind of thing. So if you accidentally come unmuted, we quickly try to mute everybody back. We'll allow for time for people to come off of mute to ask questions. So don't worry about that. You can put them in the chat box, or we'll obviously give you some time to ask questions as well. So jot down questions as we're going through if you want to wait till the end and come off mute, or you're welcome to put it in chat as we go. It's totally up to you guys what you all want to do, but I hope you all enjoy. Tonight we are going to be covering the soil topic, and soil is always a fun thing to talk about. I know a lot of people think it's kind of a boring topic, but it's a much needed thing that we have on Earth that we have to sustain life. So it's something very important. So we'll try to make it as least painful as possible and cover some of the basics of soil. Tonight with us, we do have some of our county extension agents. I know that presenting tonight will be Macy Fons. She's the horticulture agent out of Mason County. We also have Philip Konopka. He'll be presenting this evening. He's the Lewis County A&R agent. I'll be presenting tonight. I'm April from Fleming County, the A&R agent. And then we also have on Samantha Saunders. She's the agriculture / 4-H agent in Robertson County, and she'll be presenting in the coming weeks. And then we have Tad Campbell on. He's the Mason County A&R, and I don't know if David is on. I think David is on now. So David David Appleman is the A&R agent in Bracken County. So I know on behalf of them, we all thank you all and welcome you all to this, and we hope you have a great time and take some lessons back with you that you can do on your farm or help in some way around your lawn or whatever. So all right, well, we're going to get started. Does anybody have any questions before we get started? Everybody good? You can come off mute right now. If you want to, you're more than welcome to. All right, well, we'll get started. All right, and we're going to record this. So I'm going to go ahead and let Philip and Macy or Samantha, whoever wants to record it, go ahead and hit record. All right, as I said, tonight we're covering the basics of the soil. Again, this is something that's very important for us here on Earth. We have to have soil. And there's a lot of things we use soil and that we need soil for. Some of the things are, of course, agriculture, because we're pretty much all of us ladies here this evening are, somehow dealing with agriculture. Parks, gardens, all of these things we need. Building and construction, we need our barns, our homes, businesses have to have a place to be housed on top of the soil. Ecosystem services, pottery and ceramics, medicine, beauty products and treatments, they all come from soil. They all need soil. And one thing that, and I think about every agent that's on tonight, and some of y'all may have too, if you went to Morehead State University, you probably had the same soils professor, and he probably shared one thing, and it's one thing I have taken with me all these years. And I was in college, golly, in 2004, I think was when I had him first. And he said one thing that always stuck with me. He said, soil and dirt are two different things. And I know there's songs about buying dirt and things like that out there, but soil and dirt are two different things. Dirt is something that you flick off the bottom of your shoe. Soil is something that's living, it's needed. So that's something that has stayed with me. And I think, you all as agriculturalists can definitely appreciate that as well. So tonight we're talking about soil. We're not talking about dirt. And the soil is living. And when we look at soil, and sometimes we do see soil that's not living. And that's when you're seeing bare soil, you're seeing a lot of weeds, you're seeing a lot of issues. But a healthy soil should be living. You should be able to see all these things happening that's in this picture here. It's a whole ecosystem in itself. You want to be able to dig down in your soil and be able to see worms, other insects, things like that happening. You'll see in this picture a mole. All these things are good things to be happening in the soil, because it's actually going to keep all the things living in there that needs to be living and taking place to be able to provide the nutrients needed for our plants and our crops. So we want a good, healthy, living soil. And so when we think about being agriculturalists and going through this session tonight, just be thinking about what things can I do to make sure that my soil is living. If we're tilling constantly up, and some crops, they have to be tilled, but if we're continually tilling, more than likely we're not going to have much of a living soil. But if we go back and we put a cover crop on there, then we're able to add some organic matter back into the soil. So there's things that we can do, no till, things like that can help to keep our soil living. But that's something to be thinking of whenever you're planning out your gardens, your lawn, or anything like that. If you're seeing bare soil, it may be that you need to build up organic matter, that the soil may not be living in a sense. So soil is where, of course, we know our plants grow from the soil. We need soil to grow our plants. The roots get the nutrients from the soil. And sometimes we have to add other things like fertilizer to the soil, but our soil already has nutrients in it. And if we take good care of it, it can also remain a good source for our nutrients. Plants get energy. And then they put that energy back into the soil to keep it healthy and living, so that the bacteria and the fungi and the worms and other things continue happening in the soil to be able to have these nutrients for the plants to take up and keep everything going in a good cycle and keep the ecosystem going. So where does our soil come from? And a lot of times, we pretty well know this. And I know you ladies are very intelligent ladies and you know where our soil comes from, but sometimes it's just good to look back and remember and think, it's actually a lot bigger process than just showing up. It's coming from the rocks around us. Whatever is happening with the rocks and the weather and the rain and all that is breaking it down and making the soil around us. So it comes from organic materials, inorganic materials, and all of that makes up our soil. And then Macy will talk more about textures and stuff here in a little bit. But all that stuff's important because that's going to let us know what type of soil we have, what it's good for. Does it drain well? So all that stuff is very important. And here in Kentucky, because of what our rocks are made of, we have, really a high level of phosphorus in our state, which, other states may not, be that beneficial with. So it's really good to know, we've got some good soil here because of that reason. When you're looking at soil, the ideal soil you want to have, and I was talking about healthy soil and everything. So a healthy, good soil, you want to have about 45% minerals in, and then you want 5% organic matter. And for any of you ladies that submitted soil samples to the offices, you should have gotten an organic matter test as well done with it. Some of y'all may not have, but you'll get to see what your organic matter looks like in whatever you tested. So I know we had some soil dropped off here for yards, for gardens, for we had pasture fields. So there's different things. So you're going to get to get an idea, is my organic matter in that field, in that lawn, in that garden at that 5%. Also in your soil, you want at least 50% space, and that space needs to make up half water and half air. So if it's getting compacted, and we'll talk about that more here in a little bit, you're not going to have that 50% space with water and air. It's just not going to be flowing. The water's not going to be flowing correctly. So be thinking about that too as we go throughout this. And I'm going to go through this a little fast because I know we're trying to get everything in an hour. So if you've got questions, or if I go too fast, please let me know because I will definitely slow down. But the soil development is a biological process. It's a physical process. It goes through weathering, heating and cooling. You know, here in Kentucky, we have a very diverse kind of climate. So the freezing, the thawing, and all that kind of stuff helps break down and get minerals and soil and everything like that happening. And of course, gravity, water, glaciers, and wind all been a part of the soil development as well. Other things that can affect it is slope, climate, and plant cover as well, because that can alter how quickly soil forms. So now I'll turn it over to Macy, and she will talk about soil horizons and texture and all that fun stuff.
All right, can everybody hear me?
Yes, ma'am.
All right. So for the soil horizons, like April said, soil is very important. And I would go to the extent to say, even if you're looking to buy a farm, look at the soil, because, you know, you all are out there and you're going to pay for this. And especially for a farm, you know, that soil is very important. And sometimes we get into situations and you've purchased an area and you're like, oh no, the pH is off, you know, I can't grow what I want to grow. Or you find out that that sometimes some of these soil horizons are disturbed. And more of this is probably related to if you build a house, or you know, if somebody digs a pond. A lot of times these horizons can be bothered, but also, you know on our farm many years ago, you know, it was covered with trees and we wanted more room for pasture. So, you know, of course, somebody had to come in with a bulldozer and had to clean it up. So before, you know, I would say before you go out and even look at a farm, consider the soil itself and take a look at that. And Philip will go into the soil samples, but we've had a lot of people that it comes on the back end of it. They say, hey, I need a soil sample. And then things are way off on the soil sample, and it's hard to correct those. But whenever we talk about these soil horizons, there's different layers within the soil. And the different layers, it's great if you have a lot of organic matter. But if you get into a situation that you don't, then that's whenever you start to have some issues. Let me see. There we go. All right. So there's basically there's three layers. There's more, and we'll go over those. But the first layer, it goes over, basically you have the organic matter, which is on top, and then you have more of a little bit more coarse, which is your topsoil. So when you think about your organic matter, it's great if you have it. In some cases, I think we only have clay depending on where we're at. But if you have organic matter, you know, there are tests that can be done at UK to tell you how much, but you can go out and take a look and actually see, you know, do I have organic matter? And you can look for color. So you're gonna look for like a dark brown or a black color at that top surface. And that means, hey, I've got some good organic matter going here. And it's going to depend upon a number of things, but the soils are highest in organic matter based upon this dark color. And that's going to be the most fertile as well. And they're going to hold the most nutrients. You're going to have a lot of plant roots. And that's really what we're shooting for, or is that organic matter. And we'll talk about how to build that up as well. Let me see if I can get this, April. I think I'd be tech savvy by now. Okay, here we go. All right, the next one is B. It's considered the next layer down. Of course, it's more of a subsoil, and you do have organic content within it, but it's going to be a lot lower. And this is where you're going to start to see a color change as well. So if you start to see a lighter color brown and you see shades of red, if you see some yellow, you have subsoils going on. and you're going to have less nutrients within that as well. But a lot of times when we talk about subsoils, we still need that because that's where the plant gets its ability to dig deep. So it can dig deep in the soil for more nutrients and more water. So you really need that as well. And then the last layer is going to be layer C. And this is when you get into more of the rock. And it's down here at the bottom. It's the parent material. And unfortunately, this can happen when we see construction and we see more parent material within our soils, and we see rocks. So if you're not careful, if construction is not done correctly, if, for example, all of your topsoil is not put into one area and then spread back over after construction is complete, you're probably going to have parent material at the top and subsoil, and you're going to see more rocks, and you're not going to have near as amount of nutrients available. And you're probably going to have a different texture too. And we'll get into texture, but typically this is best at the bottom, and it can change dramatic. A lot of it can change within a couple of feet. So you can have your organic matter, and then a few feet down, you can have the parent material. So it's not like, hey, I've dug this huge area and now, things are not the horizons that they're supposed to be in the ways it can be. It can change very quickly. And this is just an example, and it was supposed to be laying down. So I actually stood it up, but this is a little example that we made of organic matter is at the top, and that's going to be where your best nutrients come from. And then it breaks down all the way down to where you get into the rocks that hopefully you don't see within your fields and within your gardens, but it can happen. And we ask, especially when we have plants that have issues, we say, hey, have you had construction in the last 5 years? Because if you have, what went on within that construction, because it can really disturb the roots. And then, you might not have topsoil like you thought you once had. So there's a couple different factors when we're talking about the physical properties of your soil. And you really need a soil sample, but there's things that you can look for when you go out. And there's physical properties and those characteristics that you can just look at, such as your color. You can feel them. You can look at these things and try to determine, hey, what's going on here? Is this something that would be potentially a good place to grow? Of course, we always recommend a soil sample, but the texture itself is also a very important factor. So when we talk about soil color, this is probably one of the big indicators of, hey, what's going on. So you can examine your soil and you're going to notice conditions. So you're going to look for organic content. So you're looking for the color. Is it dark? Is it light? You look for drainage conditions and then the degree of oxidation. So that's going to be the weathering. So basically you really want at the top a nice dark layer. And as you move down, it starts to get lighter. And I know a lot of people on here, you're going to say, I have clay and it's light colored. I think that's a lot of people, but we'll go over the clay portion as well. So when we talk about textures of soil, you can feel the texture. Not only looking to see if you have organic matter, you can go in and get a sample and feel it. So when we talk about the textures, there's different particle sizes. If you feel sand, like if you go on a beach, you know that it's really gritty. And the sand is going to be the biggest particle size there is. When we compare it, we look at it like the size of a basketball. And it doesn't hold water well. It doesn't hold nutrients well. And then we get down to the silt, and it's like flour. It's smooth. It's that middle. It's like it's your bread and butter. It's kind of like what a lot of people want, but nobody probably has. But that's more considered of the baseball size. And then we get down to clay, and that's going to be more the size of a golf ball. And all of these basically can compress together. And then, you know, the smaller the particle size, those are going to stick together. And, you know, you very easily, you know, that you have clay. So loam is actually considered the best soil. It's the most desired, and it's going to be made up of sand, silt, and clay. And I know it sounds crazy. Who would want clay? But and April talks a little bit more about the chemistry side of it, but clay actually holds the most nutrients, and it doesn't seem fair, right? Clay can hold the most nutrients, but then you get into the situation that it also holds water, and it doesn't have a lot of pore space for the plants to grow, but it does hold a lot of nutrients. So, and then of course, sand is, you know, it's great because it allows the water to flow through and it warms up really quick, but it doesn't hold nutrients well. So a good amount of all three is really what you want. But there's actually over 20 different classes of soil out there. It can get really complex. So now we have a hands-on part, and I'm going to share my screen, and I might stop this so I can show you guys, because we're going to go to the part that you are going to make a ribbon. So we're going to determine your texture of your soil, and I'm going to go over how to do this. If you all want to follow along, you'll need your soil, your cup of soil. You'll need water, and I have a paper plate, that's fine, or a bowl. And then you will need some paper towels. And this is going to determine your texture. And then we'll talk about altering or, you know, improving your texture, because chances are a lot of people are going to say they have clay, and that's okay. So the first thing that we're going to do, let me see here. And we have a publication on this. It's determining your soil texture by Phil. And the first thing that we want to do is grab our soil. So hopefully you guys can see. And I'm going to grab it in my hand. Let's hope I don't make a mess. Okay. And you're just going to pour a little bit of water. I'm actually right-handed, so let's see how this goes, because it's in my left hand. And you're just going to work this into a ball. Mine is actually pretty slimy right now. I'll hold this up on my computer. Okay. So you can see that it's into a ball shape. And if it's kind of sticky, you might want to add a little bit more soil to it. If it's, or if it's a kind of squeezing and water's coming out, you might want to add more soil to it. If it falls apart really easily, you need to add more water. So I might add a little bit more soil to mine because I'm making a hot mess over here. All right. Chances are you don't have sand. So if you have it and you've added water and it still falls apart, then you have sand. But I'm very doubtful, especially in our area, that we have sand. So you all should have basically at this point a ball. Ooh, ball. All right. So now what we're going to do is we're going to try to make a ribbon. So all you have to do is take it between your thumb and your finger here. Ooh, sorry, everything's backward. And you're going to try to squeeze it out and make a ribbon. Kind of like a dog turd, it looks like. So you can see that I have a ribbon here. And based upon how long the ribbon is going to be our next point. So if the ribbon breaks off at a certain point, and I'm going to tell you when, that's going to be determining our next point. So if you have no ribbon, then you have loamy sand or silt. And we'll go over how to get to that point, which one is which. Kind of doubtful that you will have it, but if you do, great. And then if you have less than an inch, then we will go over that. So basically you can have up to 2 inches long. And if it's 2 inches long or longer that you can make a ribbon, chances are you have clay. So the next point to get to is, okay, remember your ribbon. How long is it? When did it break off? Did it break off at an inch or less? So my ribbon is probably 2 inches or more, so probably clay. But then we want to see if it is gritty or if it's smooth. So what we're going to do is take our little patty here, our little ribbon, and you can break a piece off, just a little piece, and put it in your hand and put a little bit more water in here. And then you want to rub it. All right, and this is going to make a mess. So, and you just want to feel. All right, so it's making a mess. I can feel what's going on. Does it feel like it's smooth? Does it feel sandy? And I'm going to say that mine, does it feel gritty or smooth, or does it feel kind of equal? So mine is actually kind of smooth. So I'm going to say that mine is a silty clay. Now, if you have yours and you can feel the grit, that means that you have a sandy clay. Now, if it's equal, like, hey, I can feel grit, I can feel smooth, that means that you just have in general clay. Now, if you have also a ribbon that's 1 to 2 inches, so it's smaller, it's 1 to 2 inches, you get into more of a sandy clay loam. So, hey, that's probably a better situation. And it's just based upon if it's gritty or if it's smooth. If you have less than an inch, then you're getting more into the sand. So you might have like a sand loam or a silt loam. So basically 2 inches or longer, chances are you have clay, and it might be either kind of sandy, so it's gritty, or it's silty clay. If you get into the 1 to 2 inch, that's when you have less clay. So you're doing better. Okay. And then if you get 1 inch or less, you have higher amounts of sand in your soil. And then if you have no ribbon at all, chances are you have like a loam sand that you have. Did anybody have anything besides clay? Oh, well, okay. Well, we got some talking points at least. So I'm going to take a quick break and put myself on mute. And I'm going to start back my presentation and go over how to deal with some clay. So
I actually had like this is Becca, by the way.
Hey, Becca.
I had like, you were talking about like a sandy clay loam. I feel like that's what I have. Mine didn't make a very long ribbon really, but it does feel a little gritty, and like an equal parts gritty and not gritty. So, I mean, it's almost like it's really balanced.
So you might have a clay loam. If you had like a 1 to 2 inch ribbon, you had a clay loam. So you still have clay.
Obviously, I'm in Kentucky, right?
Yeah, exactly. But that's not a bad thing. Okay.
Yeah.
It's not always a bad thing, because at least you're not having a ribbon that's 2 inches long and you have complete clay.
Yeah.
So that's a good thing. So I'm going to take a quick. Yes. Yeah. You're on the better end. I think a lot of people have complete clay. So you're on the better end of it, but we're going to take a quick break. I'm going to let you guys get your hands washed up, and I'm going to share my screen again, and we'll get started back.
All right, so we did have some folks that had, let's see, Lynn said she had a 1.5 inch ribbon, not gritty. Martha said she had a 1 3/4 inch and was pretty smooth with a little grainy feel. And Amy said hers was over 2 inches, not 10 inches, 2 inches smooth. So a little variation.
Yeah, it seems like some people do definitely have more of a clay situation, but if you have a shorter ribbon, the 1 to 2 inch or less than an inch, and that's the better, I would say, that you kind of have more of the desired soil.
Yeah, and Phyllis said she had 2 inches and slightly gritty. So
Okay.
yeah. All right.
Let's see. April, can you share your screen again?
Yep.
For the PowerPoint, thank you. I've got soil everywhere over here. All right,
Can you see it, Macy?
yeah, I'm going to request control again.
All right.
And I'm going to, so I'll start in just a minute. Hopefully everybody got their hands cleaned off. I know I did not get my fingernails very well on that one, so. All right, I'm gonna go ahead and click on so you guys can go on. I'm a talker, so I don't want to take up all the time. And I had a presentation I get for Master Gardeners. It was 3 hours. So April really cut back for you all. So there's different types of soils like we talked about. And sandy soils are, probably what you see more down south. They work well for like watermelons, that type of thing. They warm up really fast, but they also leach fast. And they don't hold a lot of nutrients. They're easily tilled, but we don't see a lot of sandy soils. At least I don't. And I'm kind of shocked when I do see them in Mason County. Very few times I've seen it. And I think the one time I actually saw it was when construction had happened and they brought some soil in. So the silty soils, they have a medium holding capability. This is kind of like the middle land, and but you really want a mixture of all three would be nice. They warm up about medium during the spring, so they don't warm up as fast as sand. And then we have clay soils, and we all know about these. They have a high holding capacity for water, and they're hard to till. They're hard to, get the soil warm enough in the spring to till to get them dried out. But also, if you're not careful with these clay soils, a lot of times we think, oh my gosh, it's so warm and beautiful outside, I'm going to go ahead and plant, but our soils are not warm enough to plant yet. So that's something you have to be careful for. For the soil structure, there is different pore spaces. And if you're not careful, we get into compaction. And April talks more about compaction, but the soil particle space is really important because that's where everything grows. That's where your roots are going to go. That's where the air is, the water. It's where everything has room to move. And really you want about 50% solid matter and 50% pore space. And if you get into compaction, that's when you're going to have a lot more problems. And those plants cannot grow like they should. And any of these agents can tell you it's hard to determine what's going on with trees, or, trees are really difficult. But sometimes whenever you look at the plant, does it have a disease? Does it have this? Does it have that? And sometimes it comes back to that soil. Was it compacted? What's going on? And that's can become difficult. So you really want to have this pore space in here so that they can grow. But once it's compacted, it's hard to come back from that. So if you look at the structure overall, you really want the soil about 45% and 25% air, and then about 25% of it would be water. And then you have organic matter, which would be about 5%. You can get all the way up to 10%, which would be really nice. But 5%, I guess, is probably a good middle ground. And there's different soil structures. And some of these is just, based upon the soil that you have, of course. But each of these soil structures, some of them are more problems. And you can see things like this, the bottom left-hand structure, it can probably be more of an issue compared to the blocky. The blocky structure is probably more along the lines of what you would like to have more airspace and water. And some of these soil structures, if you look at the bottom middle one, this is when you get into soil compaction. And if you can imagine plant roots trying to grow down into that, it's going to be almost impossible. So we would like to have some of these other structures that the plants can grow in. But if you're not careful, sometimes heavy equipment, things like that can cause compaction and change the structure. And then when you think about these structures and the soil, so if you look here, the single grain and the amount of rainfall that can go through, the single grain obviously is going to be the most rapid. If you get into blocky, it's going to be moderate, which is probably a good thing. And then when you think about clay all the way over to the right, you're going to have rain come through, and then it's probably going to sit there a lot. It's going to really move very slowly. So before April takes over on this part, I did want to go over a few things on clay, because that's what we all have. And we get a lot of questions on, okay, I have clay. What do I do? I want to change. I want to change my clay. And that's going to be, it's kind of hard to do. So if you have, for example, if you have an area we had this question a few years ago, a lady had some flowers and they was not doing well. And she has clay. And I asked the specialist, I'm like, okay, what do we do? And there was a number of issues going on with the plants. And, it showed from the top up, hey, there's a disease going on. But what it really came down to is that she had clay soil. So it can be, soil can cause a number of issues. And in this case, the specialist had mentioned it was a small flower bed, but to put in wood chip or bark, to put in bark. You want to be careful not to put in pine bark, because pine bark can lower your pH, but to put in bark and then to incorporate it can cause better drainage. And, you don't want to put a lot in where it's just completely bark, but it can help in smaller situations to help with your clay. Now, I've had people also ask, can I put organic matter in? And of course, organic matter is great, but you have to be careful about what you put in your soil. It's just like anything else. Once it's in, you can't take it out. And I'll give you all an example. I had a gentleman who had a raised bed, and he said, I really want to add organic matter. I'm like, okay, that's great. So he went and bought some compost, and it was already composted, and he went and purchased it. And his pH was like at 7.5. And that's extremely high for vegetables or probably anything. It should be in, around 6.2, somewhere in there. And when he went, I said, make sure that you test the compost, because you're adding this to your soil. The compost had a pH of 8. So if he added that to his soil, he was going to have a number of issues because his pH was going to be way too high. So he ended up not adding the compost because it was going to throw his nutrients way off. So be careful what you do put into your soil. I'm not saying that you can't buy compost or not to, but just be careful. Test the compost and see what the pH is within it before you go ahead and add it into your soil. Does anybody have any questions?
All right, we will move on through. So, Macy talked about water and movement through the soil and the different ways that it can be limited through clay or move quickly through sand. But our precipitation comes through rain, snow, and also irrigation. So the way that water moves through our soil is important, like Macy said, because that's going to be something needed for our plants to grow, and can become an issue if there's too much standing in a clay situation. So drainage, and here in Kentucky, we do have drainage issues. So we want to see water not standing. We want to see it be able to move kind of quickly through soil, and you can do different types of tests on your farm to see how your drainage is. But as you see in the little chart on the right, clay is going to obviously decrease because the particle sizes are so small. They stick together, they build a wall kind of, and is slow to leach water through. And then of course sand's going to move it through really quickly. So if we can get in that middle road there, that's going to be the best place for us. Drainage too, as you can see in this picture, can be influenced by slope and the structure, texture of your soil. And again, just reminding, we've stated this a couple of different times, we want to try to have 50% of pore space in your soil filled with water. We don't want it to be standing all the time, because and many of you all have already smelled what clay smells like when water has just sat there for a long time. It gets a real dark gray color, smells really terrible, and that is a situation we don't want in our crops or on our lawn or anything like that. But we do want to make sure that, and again, we go back to a healthy soil, and a healthy soil would ideally have organic matter that would help with a clay situation. And so when you do no-till and that kind of thing, that helps in trying to put some of that green manure, as we call the plant residues, back into the soil, so that the microorganisms, the fungi, the bacteria, all that can start the ecosystem and revamping the soil in that way, so that plants can take up water from that. Organic matter is wonderful for plant roots, because it's going to allow water to be taken up by the roots a lot more readily. And just touching base, we all kind of know the issues with excess water. It's going to cause oxygen issues. It can cause disease in your plants. Most roots do not like standing water. They don't like wet feet, as we say. You can get bacteria diseases, fungus growing, things that we don't want on a root, that can cause the whole plant to weaken and be more susceptible to other diseases as well. And then on compaction, I know sometimes in farming, it seems to be a hard battle to not get into a field when it's still a little wet. So that is, something we have to fight for all the time, is, outweighing risk versus benefit. But I do see quite often calls with people with corn or something turning yellow, and they think it's something else going on, and come to find out it's compaction issues, that the roots aren't growing correctly, not able to take up water, thus not being able to take up nutrients as well, because of compaction issues, because they got into the field a little too quick when they're planting after a rain. So I know it's hard. Sometimes we seem to fight a losing battle with the weather. Here you can see in the little graph the non-compacted versus the compacted soil particles, and that's what happens. If we're driving heavy equipment over wet soils, they're just going to keep squishing, and it's going to take all that pore space that we're wanting away, and then become an issue with drainage. Soil health is going to decline, because then it's not going to be a good environment for all those bacteria, microorganisms, and all that kind of stuff to happen. But sometimes we do have to have a sacrifice type of area if we're needing to go feed cattle in the winter and that kind of thing. So just be thinking about having an area that may be lower performing or something like that, and something that can be easily revamped in the spring to be a little bit useful and not have runoff and that kind of thing as well. Here you can see a picture of a root that has been compacted. Ideally, roots we want to be flourishing. We want a lot of them. We want a lot of the smaller root hairs falling off of the larger roots as well. And so as you can see in that top picture with the green box around it, that is a root that's compacted, and it's going to have issues growing. It may eventually grow out of it, but it can have stunting and other issues, and also have a limiting of nutrients as well that can cause other issues as well. Roots just have a hard time getting through areas that are compacted. So how can you fix compaction? You can do subsoiling, you can add organic matter like Macy said, or if you're in a gardening situation, you might want to look at converting to raised beds, but I know that's not ideal for any type of thing other than gardening, but that's some options that could happen as well. So how do you tell when you can get into a field? Similar to what Macy was doing with the ribbon test, you don't have to add water or anything to it, just grab you some soil out of your field and kind of work it through your hands and see if it crumbles, then it seems to be dry enough for you to get in. But if it doesn't, then you can wait. It's more of a thing that you have to decide based on the weather it's going to be and when you have to get your crops in the field and stuff like that. But that's kind of how I'll give you an idea how you can tell when you're out in the field if it's too wet. So we're just going to touch real quickly on soil chemistry. Again, you might remember some of this stuff from when you were in high school, when we were talking about electrons and all that kind of thing. So a colloid is the smallest soil particle. It remains suspended in soil solution for a long time, and it does have a negative charge. So if you remember from chemistry, negative usually attracts a positive. So that's kind of how our nutrients get taken up and combine. Some of the elements that do have a negative charge are chloride, nitrate, sulfate, and phosphate. And we'll talk more about some of the needed nutrients for plants here in a minute as well. And then some of the positive charged elements are potassium, sodium, hydrogen, calcium, and magnesium. So you're probably starting to hear this if you've been through doing soil tests before. Some of these things are starting to click, and you're starting to think, oh, some of these things I know are on my soil test. And Philip will talk about that more later. Also on a soil test, you're going to see a cation exchange capacity, so a CEC, and it's going to be listed as CEC on there. But this is the soil's number of how many exchangeable cations it can hold. And going back to Macy talking about how our soil here in Kentucky is mostly clay, that usually means you're going to have a higher CEC. Because the higher the CEC, the more cations the soil can retain. The higher the cation exchange capacity, the more cations can be held by the soil. So clay can hold a lot of CEC. So the CEC increases with clay content and organic matter. And a large CEC indicates a soil with a high nutrient holding capacity. So these soils can retain nutrients between fertilization periods, and Macy touched on that a little bit earlier. So that can be a good thing and bad thing. So it might be able to retain nutrients, but if it's too wet or something like that, then that can become a limiting factor as well, and still have issues, because there might be plenty of nutrients in the soil, but if it's compacted, then it can be not taken up. The roots can be hindered and not be able to take up the nutrients that are there. So something else you're going to see in a soil test whenever Philip talks about it in a minute is soil pH. Pretty much all of y'all probably remember all this stuff from science class as well, but when looking at a pH range, it can be all the way up to 14, but normally we're looking middle of the road around a 7. So if it's below 7, then it's acidic soils. So if it's sour, think about that. If it's sour, then it's acidic. But if it's above 7, then that's alkaline. So that's sweet. So if you want to think, keep in mind about something to remember, just think of sweet is alkaline. So it's above 7. So soil pH adjustments can be made. If you have acidic soils and you need to raise the pH on them, then you can add lime. Wood ashes are used some. You don't see that as often as ag lime here in Kentucky. If you need to lower your pH in an instance, if you're trying to go grow blueberries or something like that needs a lower pH, then you can add sulfur, aluminum sulfate or ammonium sulfate. In some instances, urea can, if you're adding urea to a field or something, that can over time can also decrease your pH as well. Some plants can tolerate a wide range of pH, others cannot, and Philip will probably touch a little bit on this as well. I think he'll have time hopefully to show. There's one soil test we did that we showed it for 3 different crops for the same soil, and so you can kind of see that alfalfa has a different need of a pH range than just a cool season grass. So soil nutrients, and this I think is a good little picture that depicts like the roots, how important the roots are, and how we don't need compaction because our roots are very important to not only to stabilizing our plants in the soil, but that is where all their nutrients is where all their food's coming from in the soil. So the major nutrients that crops need are carbon, nitrogen, oxygen, phosphorus, potassium, and sulfur. If any of the nutrients are not there, that becomes a limiting factor. So it may be that it may be present, it just may not be in a form that it needs to be in to be able to be taken up by roots, or may be absent totally. So it's going to be limiting. And then sometimes if you don't have the right amount of one nutrient, then it might hinder the uptake of another nutrient, even if the nutrient's present. So it's very important to get that right balance with everything. So the most things that you're going to hear from us if we're working with you on a soil test is nitrogen, phosphorus, and potassium. So N, P, and K. Nitrogen's needed for leafy top growth. Too much nitrogen in some instances can mean too much growth and not much fruit production, like in the instance of tomatoes. Phosphorus is needed for root and fruit production, and potassium is needed for cold hardiness, disease resistance, and general plant durability. All of these are very important nutrients when growing plants. So now, I know many of you all took a soil sample, so I'm not going to show you the video. I'll send it to you all later. But if y'all have questions on how to take a soil sample, watch the video. If you have questions, let us know. I know we got quite a few samples in. I'm going to turn it over to Philip because he has about 10 to 15 minutes to talk. We want to try to keep y'all on an hour. But it's very important to take a good representative soil sample from your field, your garden, your lawn, wherever you're doing it from, and do it correctly, because you don't want to over apply nutrients. Over applying nutrients is a waste of money for you. It's a waste of your time. And it's also not good for the environment, because that's where you see all the talks about some of these bay areas and stuff with all this algae bloom and all that kind of stuff. It's too much phosphorus usually running into the waterways and stuff. So being good agriculturalists, that's the reason why we do soil testing and try to make sure we do it correctly, to make sure that we're not over applying, and we want to be good stewards of our earth, because that's what we do as agriculturalists. So I'm going to flip over the video again. I'll send that one out to you all. So I'll turn it over to Philip.
Thank you, April. While I'm figuring out a couple things out here, it's always my icebreaker to tell a little joke. And I can already hear Macy's eyes are rolling. But how or what language do pigs talk? Swine language. Sorry, I couldn't help myself. So let's get the view options. Let's request control. We're going to request that. And then I'm going to get hopefully a laser pointer somewhere. April, can you see my mouse? Wow. Sorry, guys. Technical
No, we
difficulties.
can't see it.
No, but I don't know if I touch it, if I'm causing issues.
Can you take it back to the fertilized example?
I think you have to. You have control. So
I have to.
Back.
There we go. All right. Now we're going to get a laser pointer. Where we was. Okay. All right. So when we get our soil samples, everything is based off of AGR1, which you have a copy of. And there is a lot of really good information in that. And if you have trouble sleeping tonight, pull it out and digest some of that information. And I promise you won't have any trouble going to sleep. But in that, some of the charts and stuff like that, it tells you how much nutrients you're removing from your crop. For example, alfalfa hay per ton. Each ton you take off the field, it's 50 pounds of nitrogen, 14 pounds of P2O5, and 55 pounds of K2O. So let's go down here to fescue hay, and then we're removing only 35 pounds of nitrogen for each ton of hay. And also in there, because every agent has had this question, I didn't have time to take a soil sample. What am I going to put down? And our answer is going to be, if nutrient recommendations must be made without a soil test, we have to assume one thing, and that is that every nutrient is low. And we're going to make a recommendation to get our bases covered. So when we get our soil samples, we're going to go buy to Hinton Mills, Rips Farm Center, Southern States, wherever you go to buy the fertilizer, and we're going to look at and get a bag of fertilizer. And there's numbers on this fertilizer, such as 4600. Those numbers are always nitrogen, phosphorus, and potassium. Okay, in that order, and they're percentages. So to keep the math simple, if we got 100 pounds of urea, 46 pounds is actual nitrogen. Okay, the other stuff is filler material. Okay, that's to help us out as farmers. Okay, I'm nowhere near as precise as David Appleman is. I mean, he is Mr. Precision. But with the filler material, I don't have to be as precise. That helps me get over the same amount of area and make an adjustment for some errors in it. So this one over here is DAP, diammonium phosphate, has 18% nitrogen, 46 phosphorus, and 0 potassium. Okay, and then we've got all our bases covered here with the triple 10. We've got 10% nitrogen, 10% phosphorus, and 10% potassium. So this is what the cover of the AGR1 looks like. Like I said, a lot of good information. So you do your homework and you get back your soil sample. All right. So that's a little bit overwhelming. So let's see if we can break this down here just a little bit. All right. We got the date we submitted it. We've got what our field is called. In this particular case, it was called lawn. I've seen them call just a little bit of everything. We want to look at this chart up here. Okay. As county agents, that's where our eyes should be going first, or at least that's where mine goes first. Okay. We've got phosphorus, potassium, soil pH, buffer pH, calcium, magnesium, zinc, and some other tests, which organic matter is ran on this one. So we've got a nice little chart over here. And it's very simplistic, low, very medium, and high. In this particular situation, our phosphorus is at 162, which is very high. If we put down more phosphorus, we're probably not going to see a response. One, that's already available in the soil, and two, the plant's going to access it. Potassium, let's take a look at it. It's in the high range. Again, we're not going to see a response. If it's not in the medium category, we're not going to make a recommendation to add more to it. Okay. Soil pH, April talked about that. Buck for buck, if money's an issue, once you get your soil samples back, especially with fertilizer prices being as high as they are, you need to pay attention to the pH. That is the most important thing that is to soil. If the pH is out of whack, it's hard for nutrients to become available. Buffer pH. A lot of people get hung up on the buffer pH. As farmers, you don't need to pay as much attention to it. What that is telling me is how hard is that pH going to be changing. Okay. If it is a high buffer pH like 7.0, that's telling me that this soil is going to be a little bit tougher to change the pH in. Not impossible, but a little bit tougher. Now, what is missing up here that was on the fertilizer bag? That is nitrogen. And the question we get is, what is our nitrogen based off of? And if you read into AGR1, because Kentucky soils are usually not frozen, but remain relatively wet through the winter, very little residual nitrogen is left over. So we don't have a whole lot of nitrogen because it goes up or it goes down. It can either go in the atmosphere or down through the water. So therefore, Kentucky crops rely on organic matter mineralization and annual fertilizer applications. For this, routine soil test is recommended from Kentucky Fertilizer. Is based off of crop response to nitrogen. So each year, our UK agronomists conduct nitrogen studies on various crops, and the range of nitrogen is picked up, and then we will take the yields, and then we will come out with an economic value. That's what we're basing our nitrogen values off of. We're not basing it off of 150 bushel a year corn or something in between. We're basing it off of those studies. So April mentioned CEC, okay? And she said, typically the higher the CEC, the more that soil can hold. I was talking to our soil scientist and he said, think of CEC as a glass, okay? If you go to McDonald's, you can get that large sweet tea or you can get the Happy Meal version. He said, as long as you keep that glass filled, it's going to keep you not thirsty. Same thing. If you have a small CEC, such as sandy soils, that may be 2, 3, or 4, we're just going to have to keep refilling our glass more often than the large sweet tea. A high CEC is in Kentucky is going to be starting at 17. Anything above 17 is going to be a high CEC. Anything below will be in moderation. So not saying CEC is the end of the world if it's low or if it's high. We just have to manage it correctly. So then we go down here to plants to be grown. Watching my time here. Tall fescue, okay? Home lawn, new planting. We looked up here, we said everything is high or very high. So if we look down here to recommendations, we don't need anything in the phosphate or potash category, but we do need nitrogen. Again, goes back to those tests. So if we come down here, it says apply 1 to 2 pounds of actual nitrogen per 1,000 square foot, okay? Timing is very important with lawns. For low maintenance lawns, add the nitrogen in one application in October to November, okay? So now's the time to be fertilizing your lawn, okay? If you want to do, for medium maintenance, you can split the 2 applications of nitrogen, September, October, and into November, December. I'm going to fall into the low maintenance category because I hate mowing the yard. So I will just do the 1 nitrogen application. If you look down here at the bottom, it will tell you the different fertilizers that are in the system that you could go to the feed mill and pick up. For example, 3600, you need 3 pounds of it. On soil organic matter, this is the kind of the way to think of it on this. If it's less than 1%, that's probably some tilled ground that's been in tobacco for several years. The organic matter's been burned up. It may be corn silage. We're not putting anything back on there. If you're from 1 to 2, you're probably in a no-till situation and cover cropping it over the winter. If you are 3 or above, you're probably in some sort of forage that has a lot of growth and in good shape on that. So the higher organic matter can be the better off we are. So we'll flip through here one more time. We'll look at the garden one again. This person, I'm assuming with everything being very high and a pH of 5.9, buffer pH 6.7, I'm going to say in the organic matter 1.84, that this has been in the garden for a few years. And they love their garden and they want to fertilize their garden very much so. But this year, they can take advantage of the high fertilizer prices and they don't have to put anything down other than nitrogen. There's a lot of different types of nitrogen out there. All have pluses and minuses. Potassium nitrate, it can raise pH over time, but it's very water soluble. So in a garden, we like that. Calcium nitrate can raise pH over time and it's water soluble. Urea is 46% nitrogen and it can volatilize. That's the problem with it. It's common, but it can volatilize. It can go up in the atmosphere or down through the water. All right, we're going to skip the rest of them. If you've got more questions on soil samples, feel free to reach out to me or any of your county agents. Through here. Let's flip through a couple more real quickly because there's something I want. All right. Every once in a while, you'll get a soil sample back here that says the pH is too high to calculate CEC. Don't be alarmed by that, okay? Anything that's over, I believe, a 7.4, UK system can't calculate it. We'd have to change a few things in our system to calculate. Doesn't mean it's high, doesn't mean it's low, just means our system can't calculate it. Now, April, let's see, how do I stop sharing this? Let's see. All right, now I'm going to share my screen and I want to show you a couple things real quick. All right, web soil survey. I heard Macy say that you want to check out your soils before you buy a farm. This is a great way to do it. It's a free tool. It's on the website. It takes a little bit of time to play with it to master it, okay? If you see this green button right here that says Start Web Soil Survey, when I first started playing with this, that little green button was invisible to me. I don't know why, but I could not find it. Once you click on that, it's going to pull up this screen. And it is a nice picture of this great country of the United States. And you need to figure out where that farm is that you want to look at. So I did that. I'm going to pick on this farm right here. This farm happens to be my Mimos farm, so I can pick a little bit on this one. The image is not necessarily up to date. That fence row is gone. It's early spring because the hay fields out, or where we fed the hays out here. And then down here is a very green spot. In this particular field, there is daffodils that come up every spring. There's 3 acres of daffodils that come up wild, and that field will turn yellow. That being dark green tells me that it's early spring. So we want to figure out what we got going on here. Here's a couple of tools up here. You can zoom in, you can zoom out. If you want to move around the screen, you have to use the hand. Don't hit that little earth, because if you have slow internet and you hit that little earth, it's going to take you back to the United States. There's a backwards and a forwards button. We can measure distances, but here's the cool feature about it. We can take AOI, which is area of interest. Okay. In order to see what soils are there, we need to mark off a field. And I'm going to do this field particularly real quick. It is going to create an AOI for me. Hopefully you all can still see this. Okay, while that's working on creating an AOI, it's going to come up and it's going to have some blue lines through this field. That's going to be the area we're looking at. Up here at the top, you can click on Soils Map, and it will pull up every soil profile that's in that highlighted area. With that, we can tell a lot of different things. What the soil's made of, drainage, slope, different things like that. And the internet is not going to cooperate with me tonight, so I do apologize, ladies. Oh, wait a minute, spoke too soon. There is our blue lines here. I can click on Soil Map. And it breaks it up for me. It tells me how much percentage in that field is made up of those soil profiles. And it tells me how much acres are in that total field. If you want to get real fancy, you can go over here and you can hit printable version. You can title it and you can print it off. You can take that to your county agent, to a different agronomist, and they can help you make some management decisions with those fields. April, I am going to stop since we are over time. Ladies, if you have any questions, you can feel free to unmute and ask, or you can catch up with us later.
All right. Does anyone have any questions? You're welcome to come off of mute, or you can type it in the chat box.
So Philip, when will our soil samples be ready to pick up?
Becky, yours will be probably ready tomorrow. I just got them in an email that says I got them in about half an hour ago, and I haven't looked at them. So I should have them to you tomorrow.
All right, thank you.
And that's a very good question too. you might notice that each county kind of has a different price on their soil test. It's usually ranges. Sometimes some counties have it for free because they have a grant or something. Like here in Fleming County, ours is $7 per soil sample. So that's kind of the reason why you'll see different counties have different budgets for their soil. So if you go to one county, it might be $7.50, another county might be $8.50, one county may be free. But if you do run a soil test and you want the organic matter added to it, you do have to let your county agent know, because we have to input that in differently. And I think that one is $5 extra. So if you want that, it just whatever the county price is, add $5 on top of it, because that's the cost to the county from UK to run that one.
Hey, April, I did forget to mention a couple of small things.
Okay.
If you do a soil sample and for some reason you change your mind, because they told me a wise man always changes his mind, a fool never does. Say we decided we were going to plant corn and then we change our mind, we're going to do soybeans. You do not have to pull a completely separate test. You can bring those numbers back into us and then we can recalculate it for you. There's some calculators, April, I'm thinking we'll email the links out to you that you can simply enter the information, the numbers up into that top part of the chart into the calculator, hit your crop, and it may ask you previous crop and soil drainage, and then it will make a recommendation. Those recommendations are based off of 100% actual fertilizer. So don't forget to do the math that you go there. If you're doing urea and it calls for 50 pounds of nitrogen, take 50 divided by 0.46 because it's 46%, and you need 108 pounds of nitrogen to equal that 50 pounds of actual nitrogen. And then lime results. If you have different quarries that you may shop around, some of them are cheaper, some of them don't have as much quality lime. Every quarry in the state that sells ag lime, we have a test result for, and it comes out in the spring, comes out in the fall, and you can access that through the web. And it's the numbers you need to pay attention to is a relative neutralizing value. The soil test recommendations are based off of 100% actual lime, and most, if not all, the quarries do not have 100% actual lime. So there is a way to adjust that for each quarry.
Yeah, and I will email out the links to all that. So the web soil survey, the link to the calculators, and the link to the lime reports as well.
I had a quick question, and I apologize for interrupting you.
Oh no, you're fine.
This is Becca Harvey. I have my soil test results, and mine says I'm high in magnesium. What do I do in that case?
What's the crop being grown, Becca?
Well, when I submitted this, I told them just, a garden, like a vegetable garden. But we're just now finishing our build actually. So we're not actually there yet.
Okay. With the exception of solanaceous crops, in April, Macy, y'all chime in here if I get it wrong. I wouldn't be overly excited about the magnesium with tomatoes and stuff like that. We can have some ripening issues. If you're doing farmers market or commercial tomato production, yeah, we might have to worry about that. Homeowners, no, we probably don't have to worry. Don't get too excited about that. We can make up the difference by adding some potassium.
Okay. Okay, great. Thank you. This is all very new. I'm very novice at this, so I'm on a major learning curve here. So
That's what we want. That's the reason why we do these classes. So, and if y'all have got questions more about your soil results or anything, let us know. We had more scenarios and stuff from some of the ones we had gotten back, but trying to keep y'all as close to an hour as possible because I know everyone's time is precious. So
I'm just going to hog up everybody's time here. I apologize. We also have a problem with giant, what we call earth biscuits. I mean, this is Kentucky, but I mean, we have a ton of just rocks. but we have also a lot of wild food that already grows within these fields of crazy rocks and stuff. So, I mean, I'm not going to really worry too much about tilling, but is that going to hinder any kind of growth? Do I need to remove these earth biscuits or just leave them be?
Is this for you where your garden is?
Yes. Well, it's everywhere out there, but
Right.
yes.
Well, is that your main thing that you're worried about?
Yes. Yes.
As long as it's not, so you have to think about like how deep roots grow.
Mhm.
And so as long as the rocks are not in that area, then you'll be fine. So if they're deeper, you won't have to worry about them.
Okay. Well, it's such a weird thing. Like, I mean, we have all kinds of stuff that seems to grow really well there, but there's a spring underneath as well. There's a natural spring there too, which is probably part of why a lot of things grow well. But it's just very
Becca-
strange how many rocks there are.
Becca, we have a rock farm too. That's what we call it. And we have picked up rocks for 3 generations and they're still here. So, but yeah, we have pretty big rocks that we have, and I think we grow more rocks, but we normally pick ours up in the garden and put them, in the driveway or different things because there's so many. I wouldn't say, we go through and plow and you'll see more, even, decades later. But I wouldn't say it hinders it. We just usually pick them up and go on. But I would say, they're going to be here. We've tried picking them all up and they're still here. So
yeah, these are like huge too, which is crazy to me that there's anything growing at all. But they're massive. Like, there's no way we could actually move them ourselves. We'd have to have a piece of equipment to move some of these.
wow.
Yeah, so they're really big, but there's also, like I said, there's wild garlic, wild onion, there's blackberries, there's all kinds of stuff just already growing out here despite all these giant rocks. So I don't know, I guess the root systems have found a way.
Yeah, as long as I guess they don't have I guess you call it like more like a hard pan. If they hit the rocks, that's whenever you're going to have some problems early.
Right.
That's whenever you're, but if they're finding water, I guess, that's the main thing, and finding that nutrients.
Awesome. Thank you for answering my incessant questioning. I appreciate it.
Now, plants are pretty amazing things. I've seen trees grow on the side of rock cliffs that there is no soil. So the only thing I would caution you about, Becca, is be concerned about tillage and how deep you do go, because you may bring up some bigger rocks that you have to deal with.
Yes. Well, we may actually just go the route of a raised bed just because of the rock issue. I hate to just disturb what's already there because obviously it's working for some things. So I hate to mess with, a good thing. So we may just do a raised bed. That may be easier on our backs as well. So we don't know.
And that's not a bad option too. So.
Yeah.
All right. Does anyone else have any questions? We do appreciate you all for joining us this evening. I know soils, again, cannot be the most pleasant thing to have to talk about or listen to us talk about for a whole hour, a little bit over, but we do appreciate you all taking the time this evening to be on with us. And again, if you start going through AGR1 or you start looking at your soil test results and you have questions, just let us know because we're happy to help and trying to walk through all that kind of stuff with you. But I will, it probably won't be this week. I'm off tomorrow and Monday, but I will on Tuesday email out the links to everything that we discussed tonight. I'll also probably send you all out a copy of the PowerPoint in case you just want it to look at. I don't know what I don't think it has a whole lot of information that you'll want to need it for, but it might have something in there that you needed to look at again. So I'll email all that stuff out to you. If you have questions in the meantime, let us know. But other than that, we will see you all next Thursday evening at 6 p.m. Virtually again. And I know it'll probably be a lot easier on some of y'all next week when we log on. So if you have problems, let us know. We're happy to help. We'll see you all soon. Y'all take care.